So this is a simple geometry problem, and in this geometry problem, you want to make sure that you use all the information given. So how do we do that? We translate the sentences into not equations, but into the figure. So the figure is enlarged for you here, and the first sentence says each of the small circles in the figure has radius 1. So we can draw a center, and a radius of 1. So the center of the circle goes to the circumference in a straight line. This is not really a straight line, sorry. In a straight line, and its length is 1. So diameter is just 2 radius. So we have a radius of 1, and a radius of 1, and a radius of 1. And then it says the innermost circle is tangent to the 6 circles that were surrounded. That means we know that the circles are touching. So they don't have anything in between, so we don't have to consider that an option. We can just say 1 and 1 if we want to connect the radiuses. Okay, so it also says, and each of the those circles is tangent to the large circle. So we also know that there isn't a space between these small circles and the large circles. There isn't any space, so we know that the radius set is already set. And it says, and to its small circle neighbors. We know that. Find the area of the shaded region. So, since the small circles are tangent to the small circles and the large circle, we already know the radius of the large circle. It's 3. The radius of the large circle is 3. Do you know why? Because one, we're starting from the center, and as you see here, the radius of one small circle is 1, and the diameter of one small circle is 2, because 1 plus 1. So radius is 1/2 the diameter of any circle. So we know that the radius is 3. So what is the radius of the small circles? The radius of the small circles is already given to us. It's 1. So it says in the first sentence that the radius of the small circles is 1. That means to find the area, do pi r squared. And if r is 1, then it's just pi. But how many small circles are there? There's 1, 2, 3, 4, 5, 6, and 7. That means we know that there's 7 pi. That's the total area for all the small circles, which is 7 pi. There's seven small circles, and each of them have an area of pi. In the large circle, since it has a radius of 3, because we already counted it, we already proved it from the center of one small circle and the center of the large circle. We also know the area of the large circle. So since it's pi r squared, r is 3, that means it's 9 pi. And if we're trying to find the area of the shaded region, we subtract the area of the large circle, large, by the area of the small. Area of the small. And that's just 2 pi. So the answer